Assalamu alaikum. So we have an analog signal here, and in this video we will sample this signal, and after sampling this signal we will get access. And how that will be like this. This is our original signal, and at the below we have a sample signal. Though the signal is not so good, but at the end of this video we will make this signal better by using a code. Okay, so let's start. So let's say this is an analog signal, and the analog signal is a sinusoidal signal where xt is equal to a cos omega t plus theta, where omega is 2 pi f, and here f is called analog frequency because this is the frequency of an analog signal. And why this is analog signal? Because you have the signal at all the time. Let's say this signal is a voltage. Let's say you are obtaining a voltage from some kind of source, so you have a voltage at all the time, and now you don't want the voltage at all the time. Instead you want the voltage at some specific time, like Ts, then 2Ts, then 3Ts, then 4Ts. So instead of taking continuous voltages, you have to take the voltage at some specific time, and here Ts is called the sampling time. Okay, so here Ts is called the sampling time. So you have to take at Ts, you have to take this voltage here, and then take this voltage here, then take this voltage here, then take this voltage here. That means after Ts time you have to take the voltages like this, and this is called our sampled signal. This is called our sampled signal, and the process, you have obtained a continuous time signal, you have obtained a discrete time signal from a continuous time signal, and this process is called sampling. Okay, so this process is called sampling. So how we can get a sample signal? We will get a sample signal from this signal. So this is our xt, it's the analog signal, or we can say that this is our original signal. So here we have take the signal across all the time, but instead of taking the signal across all the time, we will now take the signal at nts. Okay, why nts? See, 1, 2, 3ts, 4ts, then we will have 5ts. That means that means 1 to n is equal to 0, 1, 2, 3, 4, 5, and so on. So n is a integer number. So if I take nts here, we will get the sampled signal, and that is access. And what will be inside this bracket, we will see some later. Okay, now let's say this is our analog signal, and this analog signal is equal to a cos 2 pi f. F is called analog frequency, then theta. Okay, so this is our original signal, right? And now we have to get a sample signal. To get sample signal, we have to take some discrete time, let's say nts, 1ts, 2ts, then 3ts. And if I put nts instead of t, so I have to write here nts. Okay, now what is ts? You know, ts is called the sampling time, but now we have to take the inverse of ts, and inverse of time will be some kind of frequency, and this fs is called the sampling frequency. Okay, that means it is called the sampling frequency. And what is its unit? Its unit is sample per second. That means the number of sample per second. Okay, so let's 1 by ts is equal to fs, so ts should be 1 by fs. So input this ts here, so we will get a signal like this. Let's write n here, and ts is equal to 1 by fs. Let it write below the f, then theta. Okay, so now this is our sample signal, right? If you take continuous time, you will have an analog signal or original signal, but if you take some discrete time, you will have a sample signal. So this is our sample signal, and what should be inside the bracket? You will see this is the function of n, right? So this function depends on n, so we have to write n here. Okay, so f by fs could be written as small f, and small f is equal to f divided by fs. Let's try to find the unit of f. So what is the unit of f? Let's find. So this f is called analog frequency, right? And what is the analog frequency? The number of cycles per second. And this is our sampling frequency here. This is our sampling frequency. So sampling frequency means number of samples per second, and if we cut this second inverse, we will get cycles divided by samples. So this is the unit of small f. Now let's go back to our Python code. Okay, so this is our Python code. So it's a very easy code. You will get this at the description, or I will comment section. So here first we have to generate a signal. So here we have generate a signal and then plot this, and then we have sampled that signal, and then we plot this, and we take the analog frequency 1 kilohertz, and the sampling frequency is greater than analog frequency. Analog frequency is 1 kilohertz and sampling frequency is 3 kilohertz, so it's greater, right? And fs has a minimum limit, and fs should be the double of this analog frequency. We will talk about this thing at the next video. So in this case, fs is greater than analog signal, and we obtain a signal like this, but this is not a good signal, right? That means we have to increase the number of sample. So we have to increase the number of sample per second. That means we have to increase fs. Let's say fs is 10 kilohertz, and now let's see how will be the signal. Okay, it's taking some time. Okay, so this is our signal. This is our original signal. You have a continuous smooth sinusoidal signal, and see, you have a good sample signal. It looks that it's a good signal, right? Then if I again increase the sampling frequency, let's say it's 30 kilohertz, let's see what happens. Okay, it's taking some time. Okay, see, you have a better signal than previous. Okay, now so let's talk something about f, this small f. Let's talk something about this small f. Okay, so let's say we have a sinusoidal signal. In the previous slide we use a cosine signal. Now let's say use a sine signal. Okay, let's say this is our analog signal and this is a continuous signal, and let's say that the analog frequency is 50 hertz and the sampling frequency is equal to 20 hertz. You see, the sampling frequency is much more greater than f. So what will be f? F will be simply f divided by fs, so 50 divided by 20, so 1 by 4, right? So have you remembered the unit cycles per sample? So unit is cycle per sample. That means this is some kind of cycle and this is some kind of sample, right? You see, cycles per sample. So this is one might be some cycle and this is sample. That means we will have 4 samples. We will have 4 samples in one cycle, right? That means in one cycle we will have 4 samples. That means this is the cycle, right? This is a cycle, and in this cycle we have take 1, 2, 3, 4 points. That means the analog sample signal or discrete time signal might be look like this: 1, 2, 3 and 4. So we will have an idea of the behavior of sampling by observing the value of small f. Okay, so our video ends here. Thank you.